Hello and welcome back. In today's discussion, we'll be focusing on the theories prior to plate tectonics that will give us a good foundation of the evolution of theories that help shape our current understanding. Plate tectonics is a theory that is used to explain and describe the origin of geological features, including continents, oceans, mountain regions, volcanoes, earthquakes, continental drift, and more. Plate tectonics is a study of large-scale movement of numerous plates located in the lithosphere. This theory was not initially accepted by the geological community, but over time gained traction. To begin to understand plate tectonics, we need to first start off with Pangaea, which is the supercontinent that includes all the present-day continents as one giant landmass. Pangaea was first proposed by Alfred Wegener as part of his hypothesis regarding how the continents drifted apart. This hypothesis was coined continental drift. This hypothesis stemmed from a number of observations, such as how the coastlines of some continents fitted together like a puzzle piece. This observation was also made by a number of other individuals, as well along with some preliminary work with matching fossils. Wegener took this step further and gathered evidence to compare rocks, mountains, fossils, and glacial formations across oceans. Some major pieces of evidence for this hypothesis were fossil remains that were found on different continents from land-dwelling creatures that could not have swam across the ocean. The issue with Wegener's hypothesis and why it was not readily accepted was because he could not find concrete evidence to support how the continents drifted apart. Wegener unfortunately had an untimely death, and there were still questions that were not entirely answered, such as fossil remains located on different continents and controversy over the origin of fold belt mountains. Fold belt mountains are created as a result of two or more tectonic plates being pushed together. This resulted in rocks and debris to be compressed and folded into mountain ranges, for example, the Appalachians, Alps, Himalayas, and the Canadian Rockies. However, this was not known at the time. It is important to understand the previous theories before plate tectonics was introduced. One such theory that gained a lot of traction was known as contractionism, which was this idea that the Earth was once a molten sphere and had gradually cooled. This theory described the formation of the Earth terrain as a result of cooling and contracting, causing these buckles in the Earth, either upwards, which are mountains, or downwards, which created the ocean basin. This theory came with numerous problems, such that cooling couldn't possibly result in that much shrinkage. Another popular theory was geosyncline theory, which was used to try to explain the formation of the fold belt mountains and other deformations of the Earth. Geosynclines is where there was a linear channel carved into the Earth and was gradually filled with sediment. The filling of this occurred over tens of thousands of years, and folding and faulting occurred during this time of the sediment and thus formed into the fold belt mountains. This theory is now obsolete and had a lot of faults. This all changed with the use of sonar data and Marie Tharp. Tharp is credited with being one of the best cartographers of the 20th century and used sonar data collected by Bruce Heezen. These topographic maps began to reveal ridges on the ocean floor that were thousands of kilometers long. A particular range known as the Mid-Atlantic Range was discovered by Tharp. Her map supported Wegener's theory for continental drift because in order for the continents to drift apart, the ocean would have had to split as a result. Heezen dismissed her idea at first, being girl talk, because it supported the controversial theory of continental drift. Tharp was in fact correct, and she helped support Wegener's theory of continental drift. Unfortunately, Tharp's contribution to the field were not mentioned in any of the key papers Heezen published at the time in support of plate tectonics and took credit for the work. She is still to this day often left out of textbooks for these key findings. Continuing the conversations of the ocean floor, one such field of study, paleomagnetism, studies fossils, magnetism in rocks. The ocean floors are rich with ferromagnesian minerals, such as magnetite, which is an iron oxide that is strongly magnetic. When hot magma cools, the ferromagnesian minerals in crystals align themselves in the direction of the Earth's magnetic field, and this is known as the remnant magnetism. The minerals retain their direction unless they are melted and recrystallized again. Scientists began looking at remnant magnetism of volcanic rock and collecting paleomagnetic data. They found that rocks that from different ages from the same area showed different alignment directions. This was odd since this suggested that the Earth's magnetic field seemed to wander over time and was not fixed. This suggested three possible explanations for the apparent polar wandering. One, the continents remained fixed and the North Pole had moved over time. Two, the magnetic pole was fixed and the continents themselves had moved. Or three, both the continents and the North Magnetic Pole had moved over time. Of these possible explanations, only one could be correct. We now know that the second explanation was correct, and that the continents have moved over time and not the magnetic poles. Polar wandering, as you can see, was confusing to many scientists, but provided a way to map the direction in which continents had moved over time relative to the stationary poles. The movement of the continents is known as Pangaea, and over 200 million years ago, there was once a supercontinent. Thank you for joining me on today's discussion, where we discuss the origin and foundations of plate tectonics. Thank you and have a wonderful day.
1, 2, 3. G.